Okay, so I want to make sure we understand something here when we talk about not mutually exclusive situations. Remember, mutually exclusive means two events that cannot occur at the same time. So, for example, if you roll a die, you cannot land on a 3 and a 4 at the same time. You would only land on a 3 or a 4. That would be a mutually exclusive event. And in this case, remember, we add the two events. Remember, events, we can have an event A, and we can have another event, and we could call it event B. So these letters just mean we're just representing a situation, okay? And so we would add their two probabilities and get our answer when they are mutually exclusive, okay? But let's do an example where when you may have some overlap, and so they're not mutually exclusive. So I wanted to go over this example. So remember, when a die is rolled, what is the probability of getting a number greater than 2 or an even number? So this is the sample space. And we know that we have 3, 4, and 5 and 6 greater than 2. And then how many are even? Well, we've got 2 is an even number, 4 is an even number, and 6 is an even number. So as you can see, we have overlap here. 4 is in both categories, and so is 6. Because we have an overlap, that means that these are not mutually exclusive. So then we have a different formula in this case. Okay, so if the sample space is too large and we can't write it out like we just did here, then we have to use a formula. And so I want to show you how to use this formula. All right, so the formula says we have to take each event, just like we did before, but we have to add this part to it. We have to subtract their unions. Now I want to remind you that the word and means multiply in probability, and the word or means to add. So if you can see, we have the word and here. So first we're going to add the events, and then we're going to multiply the events, okay? So if we find each, just like we did before, then the same example, remember how many were greater than 2? There was 4, 3, 4, 5, and 6. So that would be event A. So I'm going to label this event A, and this would be event B, where we find here how many were even. Remember, there was 3 numbers that were even, so that would be 3 over 6. So now we have our event A and our event B. Okay? So we can go ahead and write this out. And just like it shows here, we can add our events A and B. Okay, we first add them, and then we have to subtract the union. And so they subtracted 2 over 6 because there are 2 overlap. Remember, 4 and 6 were overlapping, right? And so that's 2 that were overlapping, and that's why it's a 2 over 6. And that's how they get the answer 5 over 6. But let's say, once again, that you're not given what's overlapping. So if you don't know what is overlapping, but you do know that they are not mutually exclusive, what you're going to do is you're going to still add the fractions, the individual events, A and B. Okay? But then we're going to subtract their multiplication. So we would multiply the two exact same fractions, and we're still going to get the correct answer. So the key point here is this. This is what I want you guys to remember. If you don't know the overlap, then you're going to do this. You're going to use the same formula, but we're going to multiply the same two events A and AB, and the events A and B, we're going to multiply them, because remember, the word and means to multiply. All right, hope that helps.